Assalamualaikum and hello everyone. I'm Abdullah Akil from CS2902A and this is my MAT523 mini project titled Daily Calorie Intake versus Body Mass Index or BMI. In this presentation, I'll show how calorie intake affects BMI and how we use mathematical modeling to explore that relationship. So, what exactly is BMI? BMI or Body Mass Index is a simple number calculated from a person's height and weight. It is commonly used to classify people as underweight, normal, overweight, or obese. The formula is weight in kilograms divided by height in meters squared. While it doesn't measure body fat directly, it is a quick and useful health indicator. And now, what is calorie intake? Calorie intake is the total amount of energy we get from food and drinks each day, measured in kilocalories or kcal. It plays a major role in weight control. If we eat more calories than we burn, the excess is stored as fat, which increases our weight and BMI. Eating too few calories does the opposite. So, what's the connection? Over time, calorie intake directly influences weight and by extension, BMI. That's why it's one of the key factors in managing a healthy body. In this project, I analyzed how daily calorie intake affects BMI using real-world data. So, for this project, I had used 20 real data points that recorded daily calorie intake and the matching BMI. The dataset was sourced from kaggle.com and represents realistic human values. Here's a small example of the data. I only included 5 of the 20. These full values were used in the modeling process. To analyze the data, I applied three types of regression models: linear, quadratic, and cubic. I used the least square method in Maple to fit each model. This method finds the curve that minimizes the total error between the real data and the predicted values. Then, I compared the models based on their error magnitudes. So now, let's take a look at the linear model. The linear model follows the form y equals a plus bx. For my dataset, the best fit linear curve was y equals 14.9959 plus 0.0035x. The error magnitude for this model was 0.1190. As you can see in the graph, the line captures the general trend, but not perfect. Alright, so the next one is the quadratic model, which includes a squared term, which is y equals to 14.3510 plus 0.0040x minus 8.81 times 10 to the power of negative 8 x squared. This model gave a lower error of 0.0752, which is better than the linear model. Visually, the curve fits the data points more closely, especially at the edges, as you can see in the slide. Last but not least, the cubic model. This includes an x cubed term. The equation was y equals 11.3712 plus 0.0074x minus 1.3434 times 10 to the power of negative 6 x squared plus 1.5088 times 10 to the power of negative 10 x cubed. The error was 0.0783, which is slightly higher than the quadratic model. This suggests that the cubic curve started to overfit the data slightly. And we also looked at the residuals, or the difference between an actual and predicted values. The more random the residuals, the better the model. The quadratic model had the most balanced and randomly scattered residuals, which supports its accuracy. So, as we observe, among the three models, the quadratic model gave the lowest error and the best overall fit. This means that the relationship between calorie intake and BMI is not perfectly straight, but slightly curved. The quadratic model captures this non-linear trend in a simple and effective way. Alright, that's it from me today. Thank you for watching, and remember, Understanding this relationship helps us make better choices about fueling your body, right? The full dataset is available on Kaggle if you'd like to explore any further. I would put the link in the description. Thank you for watching. Bye.